Hi, welcome back to the channel. In today's video, we're going to talk about the state of the drone market and also our design approach and or design differentiators here at Drone Developer. So the commercial drone market is poised for a very rapid growth and also very exciting opportunities for drone designers as well as drone operators in the next decade. One of the exciting things that is happening in the industry is the FAA working to essentially authorize drones to operate in the national airspace system. And so this is going to open up a wide array of different missions, and perhaps the most exciting is the air delivery mission. And so I'm sure many of you have probably heard about UPS and Amazon starting services to ship their products to consumers, and so that is really one of the barriers, is how do we integrate drones to fly alongside commercial passenger aircraft. And so another key application I would say is that of land serving of development and infrastructure. And so that currently is about 50% or close to that of the entire drone market. And so drones are really essential when it comes to having a way for us to be able to sense, in a way, the land, right? So to develop land, also to see where certain wind patterns, they're essentially an aerial platform. So if you can put any sort of sensor on the drone, you can really sense different atmospheric quantities and be able to use drones for anything from environmental uses, ecology, and other applications that are going to become relevant in the future. Our goal here at Drone Developer is to give our clients a competitive edge over off-the-shelf drones. And so we do that in a variety of ways. So if we look at the design process for any vehicle, an aircraft actually, it always begins with defining what is the mission requirements. And from that, you're able to define your targeted range, endurance, cruising speed, as well as payload. And so there's different drone configurations. For example, conventional, there's flying wing. There's also a what we call a twin boom pusher. And so each of these configurations may have a slight advantage over the others depending on the type of mission that you're flying. And so we pay attention into all those details. And we also select the airfoils and the wing design, which contributes the most to the overall aerodynamic efficiency of the aircraft. And then we design the vehicle to fly with an optimum wing loading. And so there's going to be different wing loadings for whether you want to maximize endurance or whether you want to maximize range. And so we do that using equations, analytical formulation. We also use experimental work. We have rotor testing, for example, that allows us to match certain motors with propellers. We have CFD capabilities. We use ANSYS, Fluent, which is a modeling software, where we're able to get fairly accurate results to what the wind tunnel testing would tell us. And so using a combination of these methods, we're able to essentially fly at what we call the aircraft's maximum lift-to-drag ratio. And so if you take a look at this curve that I'm showing here, you see that you have the lift-to-drag ratio, which is essentially the lift coefficient over the drag coefficient. Now, for any aircraft, you want to maximize the L/D because this translates into higher range. And so you see that the lift-to-drag ratio is a function of the velocity, right? So you want to fly at a certain velocity that will give you a certain design lift coefficient that coincides with the maximum lift-to-drag ratio of the aircraft, right? So each aircraft has a drag polar, which is essentially the lift and drag coefficient variations. And so we do everything we can to design the best designs. And again, we use CFD in order to compute the drag polar and see where we're actually flying. That's something that you can't do with off-the-shelf because each customer is going to adapt the off-the-shelf drone towards whatever mission he may have in mind. So he may fly at a certain speed. Others may fly at a faster speed or put a different payload. And so that's always going to detract or move you away from that maximum L over D. So as we show in the plot, you have the maximum L over D, and then you have either to the left or to the right of that maximum point, depending on your velocity, your lift to drag ratio decreases. So that is in general one of our, I would say, our design approach. That is our key approach. We do have design differentiators, which other companies do not have, and we'll talk more about those. What those are is essentially our specializations in flow control, as well as reconfigurable UAV design and hybrid design, where you essentially have a hybrid vehicle between a fixed wing aircraft and then a vertical takeoff and landing, or a multicopter. And so if you'd like to learn more about this concept of the lift to drag ratio, please check out our website. We have some resources there. And we're also going to explain more on our design differentiator, so that will be a video that we'll be doing in the near future. So thank you for watching. Please comment below or subscribe to the channel, and we'll look forward to seeing you again. Thank you.